Hello, my name is Dr. Paul Cottrell, and I'm recording this on 5/12/2026 at about 9:25 a.m. Please help support the work that I do by donating on my website, the-studio-reykjavik.com. You can donate through Stripe, PayPal, or buy me a coffee. You can also be a paid member to my Patreon channel and my Substack channel. All the links are in the description of this video. All these videos I do are for free, so please help support the work that I do and take a look at the great products that I offer on my website, the-studio-reykjavik.com. I'm going to go over the animal model that was developed by the United States Army Medical Research Institute of Infectious Diseases. Now, the key authors are shown here, all working for USAMRIID. And this research paper, one of two in this video, is discussing the actual animal model. This was published in October of 2001. Why is that important? Because just before 9/11, there was a desire by the US government to increase funding for biological research in terms of countermeasures for biological agents and to increase gain of function research. Now, for coronaviruses, that research started heavily in April of 2001, and hence the SARS platform. Now, with this model, this is to study hantaviruses. Now, hantaviruses are a Category 3 bioweapon. That's what the United States classifies. It's a Category C or a Category 3, depending on the literature, but Category C bioweapon pathogen. All right, so this is part of the reason why they study this. Now they had to develop a model to be able to study it in animals. Hantaviruses are associated with two human diseases: hemorrhagic fever with renal syndrome, HFRS, and hantavirus pulmonary syndrome, HPS. Development of vaccines and therapies to prevent and treat HFRS and HPS have been hampered by the absence of a practical animal model. Here we report that the Andes virus, a South American hantavirus, is highly lethal in adult Syrian hamsters. The characteristics of the disease in hamsters, including the incubation period, symptoms of rapidly progressing respiratory distress, and pathologic findings of pulmonary edema and pleural effusion, closely resemble HPS in humans. This is the first report of a lethal disease model for hantaviruses that causes HPS. Okay, and this was published October 2001. Now let's take a look at another research article that was published in 2014. Now, what's key to the 2014 date? This is during Barack Obama's administration when the gain of function research was supposedly stopped. Okay? Stopped and then outsourced. Let's continue. A lethal disease model for hantavirus pulmonary syndrome, so this is the HPS, in immune suppressed Syrian hamsters infected with Sin nombre virus. Now, SNV is a rodent-borne hantavirus that causes hantavirus pulmonary syndrome, HPS, predominantly in North America. Now, SNV infection of immunocompetent hamsters results in asymptomatic infection. The only lethal disease model for a pathogenic hantavirus is Andes virus infection of Syrian hamsters. So that relates to the previous research article that I was showing. Efforts to create a lethal SNV disease model in hamsters by repeatedly passing virus through the hamster have demonstrated increased dissemination of the virus, but no signs of disease. So what they have through gain of function, through serial passage, in the hamster, it was able to infect, but lethality was not changed. Okay. So they, by doing the serial passage, there's mutations that take place. But in the hamster model, the Syrian hamster model for S and V, there were no signs of disease. Okay, so they've developed a virus through serial passage, S and V mutations, that led to they can be more of a carrier because it doesn't show disease. So that's an important feature that I'm talking about here. They increased SNV, which is a hantavirus, to be able to spread more in animals, but not show disease. So they've increased the capability of it being a host. In this study, we demonstrate that the immunosuppression of hamsters through the administration of a combination of dextromethasone and the cyclophosphamide, followed by infection with SNV, results in vascular leak syndrome that accurately mimics both HPS disease in humans and Andes virus infection of hamsters. Immune suppressed hamsters infected with SNV have a mean number of days to death of 13 and displays clinical signs associated with HPS, including pulmonary edema. So you have a disease model, the Syrian hamster, that is a good animal model to understand the pathology of the Andes virus and how it associates to human disease. But when it comes to another type of hantavirus that seems to be somewhat endemic in North America, which is the SNV, which is a close relative, they have passed it through, increased its capability in the hamster model, Syrian hamster model, but not show disease unless that hamster has immunosuppression. Okay. And then they can study the SNV. But how could you use that as a weapon? Well, you can now target people that have that are immunocompromised. Now, what does that sound like? If you have a society that is immunocompromised because of, let's say, a pandemic recently, and SNV starts to move around in the population, people that have immunocompromised systems will most likely start having disease by SNV, another type of hantavirus. Okay, so that's another element to doing gain of function research. If things get leaked out or forcefully dropped, then you have a problem. All right, so let's continue here. Immunosuppressed hamsters infected with SNV have a mean number of days of death of 13, days to death of 13, and display clinical signs associated with HPS, including pulmonary edema. Viral antigen was widely detectable throughout the pulmonary endothelium. histologic analysis of lung section showed marked inflammation and edema within the alveolar septa of the SNV infected hamsters. Results which are similar to what is exhibited by hamsters infected with Andes virus. Now remember, the Andes virus in Syrian hamsters mimics what happens in the human body. Okay, so immunocompromised Syrian hamsters with SNV can show similar HPS as the Andes virus. Okay, so they're using the Syrian animal model to study SNV now in Andes, but they also have developed a gain of function through serial passage of SNV that if it was released in the human population, it could affect immunocompromised individuals. Importantly, SNV, specific neutralizing polyclonal antibody administered 5 days after SNV infection, conferred significant protection against the disease. So now you can see that you infect the animal model with some sort of pathogen, in this case SNV, and then you test therapies. In this case, they were testing a polyclonal, I should say, not polymonoclonal, neutralizing polyclonal antibodies. So the animal models used for studying the pathology of the disease and also figuring a way to treat the disease, either through antiviral medication or some sort of antibody. This experiment not only demonstrated that the disease was caused by SNV, it also demonstrated the utility of this animal model for testing candidate medical countermeasures. This is the first report of lethal disease caused by SNV in an adult small animal model. So the key takeaway from this video is there was an animal model that was developed by Fort Detrick, by USAMRIID. That's the Syrian model. And that model shows pathology similar to humans in this hamster model for Andes virus. If they take that animal model and do an immunocompromised version through administering medication to suppress the immune system, they can get pathologies of SNV similar to humans in the hamster model, and then do testing, figure out what medications, what antibodies could suppress the infection, in addition to understanding the pathology of SNV. Now, one side element to this is that you can use the animal model and pass Andes virus through it to enhance features. And I'm going to go over that in another video. So you can pass the Andes virus through the Syrian model, animal model, hamster model, and develop gain of function. You can also, through suppressing the Syrian hamster's immune system, pass SNV through and get to the point where there's gain of function, where SNV actually can cause pathologies in the Syrian hamster model, even with immunocompetent hamsters. And even if they didn't do that, if the SNV ended up being leaked out accidentally or on purpose, SNV would be can target immunocompromised individuals in the human population. Now, again, the R0 value is low. The spread is slow, and there may be an outbreak and then it'll die down really quick. But what if, and I'll show this in another video, if you actually train SNV or Andes to hit other tissues that are higher up in the respiratory tract or even in the esophagus. And if you can target and train the GN and GC protein on the Andes virus and be able to attach the receptor in these other tissues higher up in the respiratory tract, you're going to have individuals being able to contract it easier. Very similar to bird influenza. Why? Avian influenza. Why is it hard to get? Because it has to attach to a deeper receptor in the lungs. But through mutations, it's getting higher up in the respiratory tract, and therefore it's easier to contract. They are playing with fire here. So please help support the work that I do. All these videos are for free. Make sure you subscribe to my channels. I have multiple channels, so it's really important to get. So just in case one of the channels go down, you can still see the content. So I have Brighteon, Bitchute, and Rumble and YouTube. Make sure you follow me on X and GETTR. You can watch me on TikTok, Substack, Buy Me a Coffee, Patreon. And if you want to help support this free content, get the great products that I offer on my store, and please donate. You can donate through Stripe, PayPal, or Buy Me a Coffee. But again, all these videos are for free. I don't put stuff behind a paywall. And the ones that are Patreon members and the ones that donate and purchase the products, they help support the work that I do. All right, it's really simple. So please, I think I'm giving you something really important to pay attention to. And I don't believe anyone is going into the detail that I'm going into. Nobody. All right, so please help support the work that I do. Thank you for listening and have a nice day.